Hello students, welcome again in this new session of learning. Today we are going to talk about a new type of operator, and that operator is bitwise operator. Its name is bitwise because it works using bits, that is binary digit, or simply we can also understand that this operator helps us to in our programming to carry out some operations in the same level as our bit is stored. So why it is called bitwise operator? Now, where is the application of this bitwise operator? So there are the various applications like network programming, data encryption and decryption, compression, graphics programming, performance optimization, etc. And what are the types of bitwise operator? So these are the all other types: bitwise AND. Uh, for this we use this AND symbol, or we use this vertical bar symbol. For bitwise XOR we use this caret symbol. For arrow, bitwise NOT, this is called tilde, we use this symbol. Left shift we use this 2 times smaller than symbol. Right shift we use this 2 times greater than symbol. So these all are the types of operator. They are called bitwise operators. Now to understand deeply or in a better way, let's take an example. So here is an example. I'll make it clear. We are taking two values here, 4 and 3, for two variables a and b. We are going to print here a and b. So since this is a bitwise operator, so what it does there, it converts this value into binary. This b is also converted into binary, and after that all the corresponding bits are multiplied. And means multiplication, so all the bits are multiplied, and whatever comes after that, that is converted into decimal, and that will be printed. To understand about that, so here is the example. A is 4, as I have taken a is 4. So if we are taking 8 bits, means 4 is stands for 000, and its equivalent is 0100 in binary. Similar for b, that is 3. Let's convert into binary, so it becomes this one. We are taking 8 bits, and after that what this AND does, it multiplies all the bits. So we can see a 1 into 0 0, 1 into 0 0, 1 into 0 0, and 0 into 0 0. Similarly 0 0 0 0. So after that multiplication, it is converted into decimal, and after conversion what happens, again we'll get here 0. So output it will be 0 for this one. Let's run it. Look here. So here is 0. It's very simple there. So this is called multiplication using bits. Next is a OR. In OR, actually, as we can see, the output is being 7. So in OR, unlike AND operator, we don't go for multiplication, we go for addition. OR means add the numbers. For that, what happens? We use here vertical bar, and that is also called pipe. Here, to answer about that, A is 4, each binary is this one, B is 3, each binary is this one, and after that what happens, this number and this number, they are added. So 1 plus 0 1, 1 plus 0 1, 1 plus 0 1, and 0 plus 0 0 0 0 0 0 0. So we get this one after addition, and it is converted again into decimal, so we'll get 7. We can see output is 7. So this was about the OR operator. Next is the tilde. Bitwise NOT. NOT means inverting all the bits, like from 1 to 0 and 0 to 1. So that is called bitwise NOT operator. And for that we use this symbol. This is called tilde, 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 and that is called negation. Means whatever you have for this number a, convert means convert all the zeros into 1 and 1 into 0. So that is a function of bitwise NOT operator. To understand again about the bitwise not. So I have taken this number a equals to 4. So how this bitwise operator works, let's see here. First of all, what happens, we are taking 8 bits, so a is 4, so this is your 8 bits after conversion into binary. So not tilde says that first of all you convert all the zeros into 1 and 1 into 0. So we can see here 0 for 1, 0 for 1, 1, 0 for 1, 1 for 0, 0 for 1 and 0 for 1. And also check its MSB. Most significant bit, we can say that most significant is 1. Since it is 1, so computer knows that, a computer thinks that it is going to be negative. If it is 0, it means it is positive. If it is 1, it means negative. Now what happens, we have to use 1's and 2's complement for the representation negative numbers. So 1's complement means again convert the 1 into 0 and 0 into 1. So 1 for 0, 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 0 for 1, 1 for 0, 1 for 0. And to find the 2's complement, we have to add 1 to 1's complement. Like this is your 1's complement and this is your 1. Let's add it. So we'll get here 0, 0, 0, 0, 0, 1, 0, 1. So this is our final version. Now we have to convert this into decimal. We can see here it is equivalent to 5. It is equivalent to 5. Now since the MSB is 1, so it is going to be negative. We have to put it here minus symbol. So at last it becomes minus 5. At last it becomes minus 5. So answer is minus 5. As you can see here, minus 5. So it is a lengthy process, but computer gives you instantly the result. Next is the XOR, that is called exclusive OR, and it works quite in the same way as the OR operator works. So output of XOR is 7. Now actually how did we get this 7? To understand about that, we have to again go for the data conversion. So here is XOR 4 for this one and 3 for this one. Again we have to add them 1, 1, 1, 1. So all other they become 0. So after converting into decimal it becomes 7. So we are getting here 7. We can see here XOR. But actually there are differences between XOR and OR. If all the inputs are 1, then it will give you 0. So that is the difference. All others will remain same. Next is left shift and right shift. Means somewhere suppose if we are having some numbers and we want to shift to right direction or the left direction by some bits, we have to use this shifting operator. They are called right shift and left shift. Left shift we represent using 2 times smaller than symbol, and the right shift we use 2 times greater than symbol. So what is meaning of left shift? A is 4, the value of A is 4 and B is 3. Simply it says that shift the value of A by 3 bits. It means shift the value of A after converting into binary by how much B is 3 bits. So again convert that into decimal and how much you will get, that will be the answer. It's very simple. For that look here 4, then left shift 3. So 4 is equivalent to this much. Yes, and here is 3 means shift by 3, that is left side. So 1 is here, so 1 now shifts to left side. So 1, 2 and 3. So now it becomes this much. We can see here 1 shifted to left side, 1, then 2, then 3. Now 1 comes here. So after shifting it becomes this much, and computer converts this converted or the shifted value into decimal. We'll get 32. As you can see, we are getting a 32. So this is called left shift operator. Next is a right shift. Right shift means shift the values to the right direction. Again let's take here example, A is 4 and B is 3. and the direction we are using right shift means shift the value of a to the right direction. In previous it was left, and now we are going to shift to the right direction. For that, what happens, same example we can take here. For its binary this much, and we are going to shift this value by 3 bits, means 1 is here, so 1 2 3, 3 bits is not here, so computer itself it takes 0, so it becomes here this much, and its equivalent decimal it becomes 0, so we'll get the output 0. As you can see here, right shift equals to 0. So these all are the issue that examples of bitwise operators, and using this we can solve many simple or the complex programming, like maybe the network or the graphics or the mixer, maybe the pixel based. I think you understood about this. If you have any confusion regarding this bitwise operator, put your comment in the comment box. I'll make you more clear. Till then, thank you, uh, and just if you like this, just give a hit, uh, give a like, press the like button, or the subscribe. Thank you.